Hi class, this is 3.7. This is about proportionality. In Module 2, we spent a lot of time on rates and ratios. For example, with the population densities, if the densities in two different countries are the same, that means we could say they have proportional densities because the ratios are equal. So that's what proportionality really just refers to, is maintaining an equal ratio. So we're going to explore that with our fish pictures here. So as you can see, I have a picture of a fish. I'm going to call this picture the original image. So that's where we're going to do some modifications to it. So the nice thing about Word is, or Google Docs, or a lot of document software, is when you click on a picture, and if I right click, I can go to this option called size and position, and it gives me the layout. It gives me the actual dimensions of my picture. So the height is 2.12 inches, the width is about almost 6 inches, and that's for this picture. So if I were to print it or something, that's exactly how it would show up. So that layout is something I've pasted here just for speed. So notice it's the same, 2.12, 5.85, height and width. So we have that picture with those specific dimensions. Now I'm going to modify it, right? So you can see that I've already modified the picture by doing what it says right here. I changed the picture by making the width 2 inches smaller. So I can actually do that with the layout commands. So notice it went from 5.85 to 3.85. Or, as you probably have played with pictures before, I could do that by kind of sliding it this way, right? So as I do that, notice the fish is getting smushed, right? It's looking a lot more. If I went the other way, he's getting stretched, right? No surprise. Let me lock him back in there. There we go. So I'm going to call this image my smushed fish, or my one that I just shortened in one direction, the width. I'm calling that adjusted image 1, okay? Just by looking at this. So now I'm looking at part A. By looking at the new image, did my adjustment keep it proportional to the original? So my hope is that you're thinking that no, it did not, right? That this should be the correct answer. Highlight it, right? So just by inspection, right, we can tell the fish got smushed, right? So let's do some mathematics behind the scenes of what's going on. So original fish, remember, had a height of 5.85. That was the width. The height is 2.12, and that's in inches. The width was 5.85 inches, and then the adjusted image had the same exact height, but the width was 2 inches shorter, right? So we can tell that shortening it in one direction seems to be keeping it not in proportion. Now let's actually see the mathematics of that. That's the goal. So use length and width to mathematically show that they're not proportional. So remember that to be proportional, if I can type, the ratio must be, I really can't type, must be equal. Now you might say, what ratios? Well, we could take various ratios, but if I said, say, the ratio of the original's height to width, that would be one way to do it, compared to the adjusted's height to width ratio. Those should be the same. So if I try that, let's just see what happens. So I'm going to take those ratios. So if I do, I want to insert just a little equation here. So I'm going to take the ratio, the height 2.1, sorry, keep forgetting which is which, yeah, 2.12 inches to the width on the bottom, 5.85. Why am I putting that on the bottom? Because I'm doing height to width, and I'm sticking with the original, so I'm kind of looking at this first row. And then height to width in the, sorry about that, make it a little bigger for you. There you go. In the other one, the, speed this up a little bit, kind of cheap. The height was 2.12 inches, but the width was only 3.85. Right? So I'm going to label these just so I have it, because we'll keep kind of referring back to different parts of this. So bear with me. So those were my height to width. So you can see what I'm doing. You should be taking notes on this. Ratios. So now the question is, are these equal? And I think it's pretty obvious without doing any work that even mathematically those are not equal. So how can I tell? Because even if I did the division, 2.12 divided by 5.85 is not the same ratio as 2.12 to 3.85. We're comparing the same height to different widths. Okay? So when the ratios are equal, we could say that the fish pictures were in proportion. Fishes? I almost said fishes. So let's do another adjustment. So I'm going to scroll down and look at this next fish picture. So it seems like in order to keep it proportional, I definitely need to change both the width and the length. So I did. I made them each 1 inch smaller. So remember, this was my original picture way up here, this guy. So here's my fish. Take a good look. Now I've done my 1 inch smaller in both directions. So does this one appear to be proportional to the original fish? Well, maybe, right? If you want, I could even maybe put him near the other one if you want. Maybe I might be able to get him to show up. So if that helps, does it look proportional? To me, this one kind of looks a little bit skinny, like stretched out in the horizontal way. So my instinct says I don't think it did. I don't think that worked. This one looks just more full. That one looks all like skinny, kind of comparatively. So let's test it out. That one's not as obvious. So here is my fish. And remember what I did. I just shortened both the dimensions by 1 inch. So the question is essentially, does subtracting 1 inch from both keep it proportional? So let's check it out. So the original height was 2.12. Got it memorized now. And the original width, 5.85. And the adjusted image now is 1 inch shorter. So 1.1 inch, 1.2 inches, and 4.85 inches. And you can tell I checked that with the actual layout sizing. So what does the ratio look like? Let's do the math. I'm going to steal my information up here so I can type faster. But you should set up the height with ratios. You could also set it up as an original compared to adjusted ratios. And maybe we could look at that too. Right, original. I'll do that second. Let's do this one first. So I've got the original fish's height compared to his width. That's no different. But then I have the adjusted image's height is 1. Right? And this one is 4.85. So this is a question now. Is it equal? Right? So we have to see. That's not as obvious to me. So there's ways to tell. Like we could divide both sides and see what we get. So I'm going to take 2.12 and divide it by 5.85. I'm just finding the unit ratio, right? If you divide a ratio, you get it per 1. So now it's 0.36 to 1. So I'll say, reducing that meant 0.36 to 1, or the decimal is 0.36. And then the other one is 1.12 divided by 4.85. Let's see what happens. Just investigating. Ooh, not the same. Okay, so the first one was in a much higher height to width ratio than the second one. Right, so this one came out, I think it was 0.23 or something, to 1. I don't know if it was 0.2 or 3 or 0.24 if I rounded it, but still they're not equal, right? So I would have different ratios. So these are not in proportion. So my instinct was no, but it wasn't a very confident no. Now I can really tell that they're not in proportion. So adding, or in this case subtracting 1 from both did not maintain proportion. Okay? Now I mentioned before that, just as a thought, and some of you may have started your ratio a little differently than me, ratios can be done different ways when you're comparing. So I could have thought, well, I'm going to compare the original to the adjusted. And I'll just do like height to height, 2.12, to the adjusteds was 1.12. So do you notice I'm doing height to height? And then over here I'll just do width to width. That would be another way to do this. It's perfectly legitimate. It would still give us the same decision. So the other ones, so I'm doing width to width, right? Pretty much stacked the way they are in the table, so that makes it easy. Keep track. These should still come out to be not equal. If you divide the values, you'll see this top one is actually about double the bottom, but that one is actually not quite as near double the bottom. So still not equal. So you have some options when you set up ratios, as long as you're consistent, right? So I was consistent, original to adjusted, original to adjusted, with height, width, width. So I'm going to stop there before our video times out, and then we'll go on to this next image 3 that hopefully we can get to be in proportion.